This must have been everybody's favorite unit from grade 10, the simplifying radicals. I don't know if you remember, this is one of the first things you did in grade 10 in math. How do you simplify radicals? What we're looking for, in this case, the first one, because this is the square root, we're looking for a factor of 98 that is a perfect square. So in your head, you're thinking, okay, what are my perfect squares? Here are some of them, and I'm not going to go too far because you can tell after a while that these numbers won't divide into 98 evenly. Okay, so I'm not gonna use those ones. I want to know if any of these divide into 98 evenly, and you should be able to see that 49 does. So that means I'm going to write this as the root of 49 times 2. 49 times 2 is 98, and 49 is a perfect square. And why did we do that? Because we can take 49 out of the square with the remainder of just the root of 2. Okay, now I told you yesterday, try to do that review sheet on simplifying radicals. Hopefully you remember this. If you don't, we need to review it. You need to ask in class to try to do a few of these, and you need to get through that worksheet from yesterday. Okay, this one is the same idea, except this time we're looking for a factor of 16 that's a perfect cube. So what are my perfect cubes? My perfect cubes are 8, 27, 64. Well, you can see these ones are already too big, too big. 8 goes into 16 evenly 2 times. What is the cube root of 8? It's 2. So there again, I've taken out a factor of 16 that's a perfect cube this time. Okay, let's try a perfect fourth root. So what we're looking for is a factor of 162 that is a perfect fourth root. What are the fourth roots? Well, 2 to the power 4 is 16, 3 to the power 4 is 81, 4 to the power 4 is 256. Hey, how come I know those? Because you were supposed to memorize them in grade 9. If you can't, it'll be a little harder, but you can still do it. Okay, you'll just have to actually multiply them out each time, make a list, and here I see that 81 is a factor of 162. Okay, so this is 3, and then the fourth root of 2. Now, there was another way that you were shown last year. I don't know if this is something that you need, but if you can't remember, factors of 162, what you could do instead, actually I'll leave that answer, and then I'll just do it another way down here. Okay, another way to do this would be to say, let's write 162 in terms of its prime factors. And if you remember how to do prime factoring, you would say, okay, well, yeah, 2 goes into there, 81. Okay, 281 is 9 times 9. And then this is 2 times 3 times 3 times 3 times 3. So I would write those all in here. 2 times 3 times 3 times 3 times 3. And then, since we're looking for a fourth root, are there any factors where there are 4 of them? Yes, there are 4 3's. That means I can take that out, and I'm left with the fourth root of 2. Okay, so that's something that you were supposed to have learned last year. We need to use that skill in this unit. Okay? Here's a couple of little ways that it's useful to have a good understanding of radicals. It says arrange them from greatest to least, and you can see here that these are not the same radical. So what I'm going to do is change these to entire radicals, and then I will be able to see. All right? I know that 5 root 2 is the same as root 25 times root 2, which is root 50. Okay? 2 root 5 is the same as root 4 times root 5, which is root 20. And 4 root 3 is the same as root 16, because root 16 is what 4 was before I took it out of the root. And then this is root 48. So which one is the least? 2 root 5 is the least. Which one's next? 4 root 3. Which one's next? 5 root 2. Okay? You know, if you ever have to decide which one is greatest or least, that's the number one method. That's the most common question. If you look at the next one, this one's much easier. These are all the same radical to the same index, which means I don't have to do any work. I can just look at them. I can see which one's the biggest or which one's the least. I can see that 8 is the smallest, and then 9 is next, and then 11 comes after that. All right, and the last one, well, we have a problem here. The radicands are different, and the indexes are different. When you see that, you can't make them the same. You can't know for sure which one is least or greatest. You can estimate, or you can use your calculator. All right, so I'm just going to write that here. This is one where you're going to have to estimate or use your calculator, because you can't make them sort of the same radicands. Okay, you know, if you look at this, you can say, well, I know that root 5 is about, you know, 2 point something. Okay, so then if I would go, sorry, the cube root of 5 is 1 point something. If I multiply that by 3, you know, maybe I could say this is going to be, you know, about 4.5, just guessing. And you could do it this way. I know that root 2 is about 1.6, so I multiply that by 4. Sorry, it's 1.4. So I multiply that by 4, this is going to be about 5.6. But I won't ask you to do that. Okay? That's just estimating, not something you're going to need to do. All right. We should quickly talk about the division property of radicals. This is actually pretty self-explanatory. If you see an entire radical like this, you can break it up into just having the radical on the numerator and the denominator. Okay, and you've actually done this already, right? If I see this, I can think of this as being the cube root of negative 16. Whoops. Over the cube root of 135. Okay, that's all the division property of radicals means. I can split it up like that. And now I can simplify. Okay, so I'm going to simplify the top into, is there a factor of negative 16 that's a perfect cube? And on the bottom, is there a factor of 135 that's a perfect cube? Now, let's do the bottom first. 135, is there a perfect cube factor of that? I think 27 will go into there evenly. And why do I know that? Well, my perfect cubes are 8, 27, and then right away the numbers get much bigger. Okay, and if I look at that, this is the only one that even has a chance, because the other ones are even. Okay, so 27 goes in how many times? 5. And when I look at the numerator, I'm looking for negative 16. Is there a factor of negative 16 that's a perfect cube? Well, when you have an odd index, like 3, always put the negative in the one that you're taking out. Okay, if that was even, you wouldn't be able to do that. But the cube root of negative 8 is negative 2. I can do that. So I'm going to take the negative out when possible. Okay, and then this one is going to be 3, cube root of 5. And then I can rewrite this now as 1 radical. Okay, so that would be a good final answer like that. All right, write this an entire radical. That means we want the whole thing to be in 1 radical like that. So this one's a little bit easier. What I'm going to do is take negative 3, and I want to put that inside a 4th root. Okay, can I put the negative in here? Well, the 4th root of a negative is not possible. So in this case, I have to leave the negative out here. Okay, now 3 is what before you took the 4th root of it? In other words, the 4th root of what is 3? That's 81. Okay, and if I want to simplify this now, I'm going to have the negative in front. If I multiply 81 times 2, I get 162 over 27. And I should try to simplify that. I think it actually does simplify. 162 divided by 27 is actually just 6. Okay? All right. Now this is probably the trickiest piece of this lesson. This idea of where is a radical defined. Another way of saying defined is allowed or permissible. Okay? What we're asking for is what can be underneath here? What is allowed to be underneath there? Well, you know that when we take the root of something, this number here must be a positive number. Why must it be positive? Because if you're going to take the square root of a negative, you don't have two numbers that when they multiply together give you negative. For example, could it be negative 4? Well, the only way to get negative 4 is to have 2 times negative 2. Those are not the same. You can't do the square root of a negative number. Okay? So, if I know that what's underneath the radical must be positive, and 27 is already positive, I know that x squared must be positive. Now the question is, what can I put in for x that when I square it, it will be positive? Let's just try a couple. If I put a 3 in there, is 3 squared positive? Yes. What if I put like 15? Sure, any positive number is going to work. What if I put 0? Is 0 squared positive? It's 0, and you can take the square root of 0, so that's okay. What about negative 2, let's say? If I put negative 2 in there and I square it, it becomes positive 4. That's still okay. In other words, I can put in anything for x. So I'm going to write this as x. Now you can write it in a couple ways. We could say x is in the set of negative infinity to infinity. That means x is anything. Or you could say x is in the set of real numbers. That's another way of writing that. Okay, let's try the next one. So I see index is 4. That means this number must be positive. Okay, so if it must be positive, let's consider that. That means negative 12x cubed has to be greater than or equal to 0. Well, if I want that number to be greater than 0, what has to happen for x? Negative 12 times what is going to give me a positive number? Well, that means that number has to be negative. I should learn how to spell here. So, if I take a negative number and cube it, it still stays negative. So in this case, x has to be in the set of negative numbers. Negative infinity to 0. Or you could say x must be less than or equal to 0. Okay, by the way, you don't have to do both of these, one or the other. So let's try this question. Here's the kind of question you're going to get for homework today. It says, for which values is the radical defined? Okay, so that's part 1, and then simplify. So first of all, let's think about a. What does a have to be? This is an even power. That means a, when I square it, has to be a positive number. This means a can be anything. Okay, now let's simplify. Is there a factor of 45 that's a perfect square? Yes. 9. Is there a factor of a squared that's a perfect square? Yes. A squared is perfect. So taking the square root of this, I get 3a and the square root of 5. And that's a good answer. And that's an answer I will accept this year. But it's actually not totally correct. And this is what we talked about yesterday, where that absolute value sometimes is going to come into play. Think about this for a second. Yesterday we didn't have a squared there. We had x squared. And what did we say the square root of x squared always is? It's always the absolute value of x, because this must be positive. Because when you take a number out of a square root, only a positive number is going to come out. So if we know this, the square root of a square has to be a positive value, I need to go over here and say, hey, a has to come out of a positive number. Because over here, we said a could be negative infinity to infinity. It could be a negative number. So we need to make sure in our answer it's like that. Now, again, you're not going to see this very often. I think it's like 1 or 2 homework questions, and I won't put it on the test. I just want you to be aware that the number that comes out of a square root will always be positive. Always be positive. Okay? So let's try another one. First of all, what can b be? Well, this is a square root, so this number has to be positive. If that has to be positive and you already have that negative there, that means b to the 9th has to be a negative number. That means b has to be negative. All right, let's simplify. Is there a factor of negative 27 that's a perfect square? 9. I can't take the negative out this time because it's an even index. Is there a factor of b to the 9th that's a perfect square? Yes, b to the 8th. And if I simplify that, this is going to be 3b to the 4, negative 3b. And since this is b to the 4th, I don't need to put the absolute value on it because it's already going to turn positive. Any value of b, if I put it to the power of 4, will be positive. Okay, so that answer is fine just like it is. Let's try the next one. Here we have an even index, so z must be positive. And simplifying, is there a 4th root of 7? No. Is there a 4th root of z? No. This means it can't be simplified. All right. Here we have an odd index. This tells you that this number inside the radical can be positive or negative. That means y can be anything. Maybe you want to do this, or maybe you'd rather do this. Either one is okay. Okay, so we need to know what is the factor that's a perfect cube of 24. It's 8. That leaves me with 3. And then y to the 5th. That means there are 5 y's. Well, let's take out 3 of them, and we'll leave the other 2 here. Okay, so the cube root of 8y cubed is 2y, and what's left over? 3y squared. All right, little bit of a tricky concept with those radicals in there and the variables. So I'd like you to try these questions. Make sure you get a good handle of them. If you don't, come to class, ask the questions. We need to go over this. Okay?